Good morning, students. We'll start with the today's lecture. In the previous lecture, we have seen what is capacitance, the parallel plate capacitor, and several capacitance example. That is, a capacitance of a coaxial cable or coaxial capacitor, and capacitance of a spherical capacitor. That we have seen, and we have seen what is a composite parallel plate capacitor. If there is more than one dielectric material in between the two metallic conductor plates, then we say that it is composite parallel plate capacitor, right? Then if the dielectric boundary is normal to the plates and dielectric boundary is parallel to the plates, two cases we have seen, right? If the dielectric boundary is parallel to the plates, then we view that series as capacitors are in series, right? Then if the dielectric boundary is normal to the plates, then we see that arrangement as capacitors are in parallel, right? And okay, we will continue with the numericals in today's lecture also. We will solve the numericals based on the composite parallel plate capacitor, right? Okay, this diagram is not given. By reading the question, we have to draw this diagram, circuit diagram, right? A parallel plate capacitor with a separation of 1 centimeter has 29 kilovolt applied, right? So 1 centimeter separation, these two are metallic conductors, right? 1 centimeter is the distance between these two. Then 29 kilovolt is the supply voltage, right? That is applied to this capacitor, 29 kilovolt, right? This is the diagram you have to draw. Separation of 1 centimeter has 29 kilovolt applied when air was dielectric fused. Yes, in between the two metallic plates, air is the dielectric material, right? Air is the dielectric material. Assume that the dielectric strength of air is, it is given 30 kilovolt per centimeter, and thin piece of glass with epsilon r equal to 6.5 s with a dielectric strength of 290 kilovolt per centimeter with thickness 0.2 centimeter is inserted. Earlier air was there and piece of glass having thickness of 0.2 centimeter is inserted here. Means this is composite parallel plate capacitor. Two different dielectric materials is there. One is air and another one is glass, right? So out of 1 centimeter, if the thickness of glass is 0.2 centimeter, then remaining the thickness of air is 0.8 centimeter, right? Totally 0.8 plus 0.2, totally 1 centimeter, right? Okay, find whether glass will break or air will break. Dielectric strength of air and glass is given. So if the dielectric strength exceeds of whether that of glass or air, then only it will break. We'll see that, right? Okay, and we have to assume the area of cross section, it is not given. So area of cross section A is equal to 1 meter square, right? Area of cross section of the plates, right? 1 meter square, 1 meter by 1 meter, right? The plates. Okay, what we have to find out is dielectric strength E of air. What is the electric field intensity of air? What is the capability with will withstand? E of air and E of glass. Dielectric strength is given, that is of glass is 290 kilovolt per centimeter. We will calculate. If it is more than this, then the glass will break. If it is less than this, it will not break. Then dielectric strength of air is given 30 kilovolt per centimeter. If the uh, electric field intensity, what we found out, if it is greater than this, then the air will break, right? If it is less than 30 kilovolt, air will not break. That we'll see one by one, right? Okay, we'll see. We'll take up. Okay, this capacitor arrangement, right? It can be viewed as the capacitors are in series. Capacitors are in series, right? So this arrangement, composite parallel plate capacitor, right? Composite parallel plate capacitor. Because dielectric boundary is parallel to the plates, right? Okay, so we will find out the total capacitance or C equivalent, right? Okay, 1 divided by 1 by C1 plus C2. Here instead of calling C1 and C2, we will call it as C air and C glass, that's all. Capacitance due to air as dielectric material, we can call it as C1 also, no problem, plus C glass. We can call it as C2 also, right? So C air into C glass divided by C air plus C glass. C1 C2 by C1 into C2 is C1 plus C2, right? The same thing. Take LCM, this will go to numerator and here add them, right? Okay, we'll try to find out what is the capacitance of air, what is the capacitance of glass, right? One by one. So capacitance due to air. How to find out? So we'll use the dimensions epsilon air, right? Let me call it as epsilon into what is the surface area of the plate. It is given, it is fixed by the distance d1 air, right? d1 is 0.8 centimeter. What is epsilon? Epsilon naught into what is the epsilon r for air? It is 1, right? So epsilon naught into 1, epsilon r is 1, right? So epsilon is equal to epsilon naught into epsilon r. For air, epsilon r is 1, so epsilon is equal to epsilon naught, right? Epsilon r is 1 into surface area is 1 meter square, it is given, right? Divided by d1, d1 is 0.8 centimeter, 0.8 into 10 power minus 2. So we'll calculate this. Epsilon naught is 8.854 into 10 power minus 2. Substitute here. So 8.854 exponential minus 12 divided by 0.8 exponential minus 2. So I am getting it as 1.106 into 10 power minus 9 farads. Similarly, we will find out C capacitance whenever the glass has dielectric material. C glass, we will call it as epsilon s by d2. This is the distance or thickness of the glass, right? Okay, epsilon naught 8.854 into 10 power minus 12. Then what is the epsilon r for glass? Relative permittivity is given 6.5, right? So 6.5 into 1 meter square divided by d2. d2 is 0.2 centimeter. 0.2 into 10 power minus 2 meters. So calculate it. 8.854 exponential minus 12 into 6.5, okay, divided by open bracket 0.2 exponential minus 2. So I am getting this as 28.77 into 10 power minus 9 farads. See, we want to calculate E air and E glass. We know that E is equal to V by D or V by D. Here D it is, right? V by L, volt per meter, right? So we want to find out what is the V due to air and V due to glass. So we know that the basic relationship C is equal to Q by V, right? So in order to find out V, we want C and Q. So we are calculating this C air and C glass and C equivalent, right? We'll see it one by one. So just I'm giving the hint further what we have to do, right? Okay. The next we'll substitute C air and C glass here and we'll calculate C equivalent or C total. C air into C glass. C air is how much? 1.106 into 10 power minus 9 into C glass is 28.77 into 10 power minus 9 divided by this one. I am using C air into C glass divided by C air plus C glass, right? So 1.106 into 10 power minus 9 plus, so 28.77 into 10 power minus 9. So you'll see this 1.106 exponential minus 9 into 28.77 exponential minus 9 close bracket divided by open bracket 1.106 exponential minus 9 plus 28.77 exponential minus 9. So it turns out to be 1.065 into 10 power minus 9 farads total capacitance, C equivalent or C total, right? So next we want to find out V. V is equal to Q by C, right? Q by C equivalent. So what is Q? Then total charge on the plates we don't know. We have to calculate. C we came to know, C equivalent, right? Then what is the potential difference they are given? Yes, the potential that is applied across the plates is 29 kilovolts, right? Total. So you'll find out the total charge. C is equal to Q by V, no? C equal to Q by V. So we can find out the total charge on either of the conductors. What is the total charge on either of both the conductors, on either of the conductors, right? Q is equal to C into V. Here C is nothing but your C equivalent, total capacitance into the applied voltage. So C equivalent is 1.065 into 10 power minus 9 into voltage applied. It is 29 kilovolt, right? So 29 kilo means 10 power 3. So these many columns, right? So 1.065 into 29. So I am getting it as 30.885 into 10 to the power of minus 9 plus 3 minus 6 coulombs, right? So Q is equal to 30.885 microcoulombs, or simply 10 power minus 6 coulombs, right? Total charge we have found out, right? Then next I want to find out what is V air and V glass. How to find out V air and V glass, we'll see. So V air, the potential, right? What is the potential across the capacitor that is formed by air, and what is the potential that is established across the capacitor that is formed by glass? So let me call it as V air and V glass, right? So V air, so take V, Q by C, right? So total charge Q by C air. We will not take total capacitance, only the capacitance of the air we will take. So we will calculate this. Similarly we will calculate V glass, that we will see how to calculate, right? V glass, let me calculate V air first. So Q total charge we have found out 30.885 into 10 power minus 6, and what is the capacitance of air? Capacitance of air is 1.106 into 10 power minus 9. So we will calculate the potential here. So 30.885 exponential minus 6 divided by 1.106 exponential minus 9. So it is let me write it, 27.924 into 10 power 3 volts, right? Volts. So I want V glass. So total potential across the plates that is applied is 29 kilovolt, right? So it is nothing but V air plus V glass, right? V glass, if I want what to do, so total potential V is equal to V total is equal to how much? V air plus V glass, right? So already V air we have calculated, so I want V glass. So V total, that is applied potential V, let me call it simply V minus V air. So what is V? 29 kilovolt, 29 into 10 power 3 minus what is V air? 27.924 into 10 power 3. Or else you can calculate V glass just like Q by C glass also I can do. I will get the same value, right? So I'll subtract 29 minus 27.924. So I am getting it as 1.076 into 10 power 3 volts. So next we'll find out the dielectric strength. It is given dielectric strength is 290 kilovolt per centimeter for glass and 30 kilovolt per centimeter for air. So we'll find out the electric field intensity, right? E. So let me find out first E air. E air is equal to V air divided by air is D1. So V air divided by D1. D1 is the thickness of the air, right? So V air is how much we have calculated? 27.924 into 10 power 3 divided by D1 is how much? D1 is 0.8 centimeter, right? So you can observe here the dielectric strength of air is given in 30 kilovolt per centimeter they are given. So let me keep it in per centimeter only. So what is D1? 0.8 centimeter. Let me write 0.8 centimeter. I will not write 10 power minus 2. Let me express in terms of volt per centimeter only, because I want to compare so that it will be easy for me. Centimeter, right? Okay, I will calculate 27.924 exponential 3 924 exponential 3 divided by 0.8. So I am getting it as, okay, let me keep in terms of kilo only, because they are given in terms of kilo only, right? So 27 point exponential 3 I will not take. 27.924 divided by 0.8, that's all I will take. So I will write here 34.905 into 10 power 3 is nothing but kilo volt per centimeter. I am expressing in the same units, right? Okay, let me similarly we will calculate E glass. So V glass divided by D2, I think, right? D2 is the thickness of the glass, right? D2. So V glass, it is there here, 1.076 into 10 power 3 divided by D2 is how much? 0.2 centimeter. 0.2, let me express in terms of centimeter only, right? So 1.076 divided by 0.2. So I am getting it as 5.38. 5.38 kilovolt. Kilo means 10 power 3 kilovolt per centimeter. But we will compare the dielectric strength. I will write in the bracket of air. What they have given of air? Dielectric strength of air is 30 kilovolt per centimeter. They have given. This is given 30 kilovolt per centimeter. This is the dielectric strength. What is the dielectric strength of glass? Dielectric strength of glass is of air is 30 kilovolt. I have written here air. 1 minute. And dielectric strength of glass, right? 290 kilovolt per centimeter. 290 kilovolt. 290 kilovolt per centimeter. Observe. See here. Here what we calculated is 34.905 kilovolt per cent. It is exceeding 30 kilovolt per centimeter. So if it is less than this means so air will break. Air will break. Because the dielectric strength, the capability of the dielectric material to withstand this much of voltage, right? It is not more than 30 kilovolt per centimeter. But here what we calculated, it is 34.9. So it is exceeding this dielectric strength. So air will break. Just check this glass, 5.38 kilovolt per centimeter. But it can withstand 290 kilovolt, right? It is very huge value. But what we are getting is very less value, 5. So this will not break. Glass will not break. Glass will not break. It will not break. So which will break? Air will break, right? I hope you understood this problem. If any doubts, you can unmute yourself and speak to me. Find whether glass will break or air. Here we have found out that air will break, right? Okay, the same solution I have put up here. So I'll take up the next problem. This is the last problem of this chapter and we'll wind up this chapter. So, and this is the higher portion finishes today, right? Okay. Yes, this diagram is given. The width of the region containing epsilon R1 as in figure 5.24 is 1.2 meter, right? It is 1.2 meter, this width, right? It is 1.2 meter. Find epsilon R1, this we have to find out. If epsilon R2 is 2.5, it is given. And the total capacitance, right, is 60 nanofarad. Just observe here, this is dielectric plate, metallic plate. It of surface area is 2 meter by 2 meter. These are the sides. So if this is 2 meter means, so 2 meter minus 1.2. So another dielectric material, its width is 0.8 meter. 1.2 plus 0.8, it is 2, right? Okay. The dielectric boundary is normal to the plates. So dielectric boundary is normal to the plates. Dielectric boundary is normal to the plates. If dielectric boundary is normal to the plates, we can view the capacitors are in series or parallel. It is parallel. Capacitors are in parallel. So in order to find a total capacitance, this is equal to C1 plus C2 if the capacitors are in parallel arrangement, right? So C equivalent they are given, whatever they are given, I'll write C equivalent is 60 nanofarad. Total capacitance they are given 60 into 10 power minus 9 farads, it is given. Then what about epsilon R1? We don't know. We want to find out what is epsilon R1. Then epsilon R2 is given, that is 2.5, right? And width they are given. We'll see one by one. Okay, first we'll find out C1 and C2. What is C1? Epsilon 1 into surface area is different here. Let me call it as S1, surface area, right? One side is 2 meter and this side is 1.2 meter. Surface area is different. Let me call this as S1. S1. I am writing here S1, right? So epsilon S1 by D1. What is the separation between the two plates? Let me call it as, here the distance is same. Let me take it D only, right? From here to here, it is 2 mm only, right? Height 2 mm. Separation between two plates. So what is epsilon 1? epsilon naught into epsilon r1 into surface area S1 by d. So let me substitute and write 8.854 into 10 power minus 12. What is epsilon r1? We don't know. We have to calculate. What is surface area? Observe here. One side is 1.2 meter. 1.2 into 2. So surface area is 1.2 into 2. Right? Meter square. 1.2 into 2. Surface area S1. D is 2 mm. 2 into 10 power minus 3 meters. Okay, we will calculate this, how much we will get, and next we'll see. Okay, 8.854 open bracket 8.854 exponential minus 12 into 1.2 into 2 divided by 2 exponential minus 3. So it turns out to be 10.624 into 10 power minus 9 epsilon r1. Okay, we'll keep this as it is in terms of epsilon. Similarly, we'll calculate C2 epsilon 2 surface area. This one is S2. One side is how much? 0.8, another is 2. Right? So surface area S2 divided by D. Height is same. The width, the difference, the distance between two plates. So epsilon naught epsilon r2 into surface area 2 divided by d. So epsilon naught is 8.854 into 10 power minus 12 into epsilon r2 is given. How much? It is 2.5. So 2.5 into surface area. Yes, 0.8 is one side, 0.8 into 2. So 0.8 into 2 divided by d square, that is height is 2 mm, right, between the two plates, 2 mm. 2 into 10 power minus 3. So we'll calculate this. So 8.854 exponential minus 12 into 2.5 into 0.8 into 2 close bracket divided by 2 exponential minus 3. So I am getting it as 17.708 into 10 power minus 9 farads. Okay, we will make use of equation 1. Equation 1 implies, because we want to calculate epsilon r1, right? So equivalent is how much? 60 nano. 60 into 10 power minus 9. This is given. What is C1? C1 we have calculated 10.624 into 10 power minus 9 epsilon r1 plus C2 is how much? 17.708 into 10 power minus 9. So we will calculate epsilon r1 directly. So how much you will get, we'll see. So I will take this 17 points, that's it, right? 60 minus 17.708. So I am getting it as 42.292. 42.292 into 10 power minus 9, right? 10 power minus 9 are taken. So divided by 10.624. So I am getting it as 3.98 after calculating, because this 10 power minus 9, if it is divided, it will get cancelled. So I have not taken that, right? So let me check it, this is right or wrong. 3.98. I have the solution here. 3.9823 they have got, right? Okay, so 3.98, right? This completes this chapter. If any doubts, anything, you have to